Hello everyone. So let's continue our analysis of this AC network. We had already tried superposition theorem and then we also tried Thevenin's theorem. So we got the same answer for both. Now I want to solve the circuit and find the current in the 5 ohms resistance using mesh analysis. So let's do some bit of mesh analysis, or I also call it as matrix representation method. So let's do that. So what is mesh analysis? So in the circuit that is given to you, you mark, like there are two meshes. So this is one mesh and this is the another mesh. So you mark kind of current direction in the anti-clockwise direction like this. So let's call this current as I1 and let's call this current as I2. So I have two currents I1 and I2 flowing in this. So that is the first part of the method for solving using mesh analysis. You you identify the currents in the loops. If there was third loop, I can also give a third mesh, third loop with I3. So make sure that you cover all the components of the network in this mesh, so that at least in one loop, every item is covered. Okay, so what is the next step? So next step is you apply Kirchhoff's voltage laws. So apply KVL for each loop. So let's look at the first loop. So the first loop here, I start at this corner, and then from here I go up to this point. So since the current direction is I1, it is like this. So the current flows from high voltage to lower voltage. So my potential will drop. So I should give a minus sign, minus I1 multiplied by minus J4. So this is the voltage drop from here to here. Now at this point, I am moving upwards. So from negative side, I am moving to the positive side of the voltage source. So my voltage increases. So I'll say plus 40 angle 0 degrees. Now I am at this point. So from this point, I come to this point. There will be a voltage drop here. The voltage drop again will be from high voltage to low voltage. What I mean to say is here the voltage will be high and here the voltage will be low. So when I move from this point to this point, the current also flowing in this direction, so it will drop. So to signify drop, I say minus I1 and then into J3, current into impedance. Now I am at this point, so I want to come back to my original point. So the thing is here the current is I1 minus I2 because this is a common for both loops. So the overall current is, but then still it is a drop. So here the voltage will be high and here voltage will be low, so it will be a drop. So minus of I1 minus I2, and then the impedance is 3 ohms. So now I'm back at this point, so the voltage will be 0. Let's do for another loop. So I start at this point. You can start at any point. You can start here, you can start here, any of these 4 points you can start. I just start at the lower right and then I do. This is just my practice. So from here to here, if I go, the voltage will be dropping I2. So that's why minus I2. I2 is my current in this branch, and the impedance is J6. Now I am at this point. So from here to here, when I go up, actually the current will be I2 minus I1, but then it will be a voltage drop. So minus I2 minus I1 and all multiplied by 3. So now I am at this point. So from this point to this point, already there is a voltage source. So I am moving from plus side to the minus side. So my drop, there is a drop in my voltage. So I should give a minus sign. So minus 30 and the angle is 45 degrees. So I'm at this point now. From here to here, again my voltage is dropping. The current is I2. So minus of I2 into 5 is equal to 0. So I have two equations. And if you notice, there are two unknowns. So it's a matter of now solving two equations with two unknowns. So let me just write it in a more convenient way. So all the constants, I'll take it to the right side. So and the variables, unknown variables, I'll write it here. That is I1 and I2. And then the rest of the coefficients of these unknown variables, I'll write it here. So let's see that. Now look at the first equation, and what are the coefficients of I1? So this will be a 2 by 2 matrix. So let me make two columns and two rows place for that. So look at the first equation. So minus of j4 minus j4. So it becomes plus j4. So here I will have j4. Then this is a constant. So it goes to the other side. So it becomes minus 40 angle 0 degrees. Then again minus I1 into j3. So j3 is plus. So it will become minus. So minus j3. So this whole thing will get multiplied with I1. And then there is a minus I1 into overall 3. So it will be minus 3. So that is the coefficient of I1. And what is the coefficient of I2? So if you look at this entire equation, coefficient of I2 is minus into minus will become plus, and then it will be 3. So 3I2 is the coefficient of I2. Look at the second equation. So now let me look at the coefficient of I1 only. So this is I2, so this is I2. So minus minus, and then minus into minus will become plus, and then there is a 3. So the 3 will come here. And then this minus 30 angle 45 will go to the right side. It will become plus 30 angle 45 degrees. Then now look at all the coefficients of I2. So I have minus j6 here. Then I have minus 3 here. Then I have minus 5 here. Like this. So I have two unknowns, two equations. So if I further simplify, this will be minus 3 minus plus j. So minus 3 plus j or 1j. And this is 3 and this is 3. And this will be minus 8 minus j6. So minus 8 minus j6. This multiplied by I1, I2 will be equal to, so this one is minus 40. Since the angle is 0, I'll just put plus j0. And then this will be 30, 45 degrees. So this one I should convert to rectangular form, but for the time being, I'll just keep it like this. So I have this AX equal to B. So from this, so X is nothing but A inverse B. So let's do that. So for this now I will use my MATLAB interface. So I define these variables. So A matrix is equal to, so the first element is minus 3 plus j. So minus 3 plus I. So remember in MATLAB we use I in the form in place of j. Then I have 3. Then the second row I have 3 and minus 8 minus j6. Minus 8 minus 6i. So this is my A matrix. So A matrix is defined. Then let me define my B matrix. So B equal to, the first element of B is 40 and then the second row. So remember this semicolon is for separating rows. So B matrix is 30, 45 degrees. So 30 into EXP. So I into 45 degrees divided by 180 multiplied by pi will convert it into radians. So this will create my B matrix as you can see on the screen. Now X is unknown, so X is nothing but inverse of A multiplied by B. So let's do this. So I'm getting the value of X. So this is nothing but the currents that are there in the circuit. So did I make any mistakes? I think the B is minus 40. So here I made a mistake. So this should be minus 40. Yeah. So now again calculate X. So now I got the correct value of X. So now X is nothing but our I1, I2. So from this, so solving using MATLAB or actually Octave. I'm actually using Octave. Octave is a open source programming language which is having the same syntax of that of MATLAB. So you can do that. So I have I1, I2 is equal to, so 13.2 plus J2.1 and then 0.58 minus J 2.296 amperes. Now, what we are interested is the current in the 5 ohm resistance, which is nothing but the I2. So therefore, our final answer is I2. So what is our final answer expressed in polar form? So let's do that. So I2 here is x of 2. That one I'll say absolute value of it, and then angle of it, angle of x of 2. So this one will be in radians, so I'll convert into degrees by multiplying by 180 and dividing by pi. So minus 75 point. 2.3687, 2.3687, and the angle is minus 75.82. So now if you notice, we got this exact same answer using the other two methods also, 2.3687. So if I go back to my earlier method, page 4, this was the answer using the superposition theorem, 2.3687 and minus this. And if I go to page 5, this was the answer which we got using. So I hope you can see here 2.3687 minus 75.8 degrees. This is the answer using the Thevenin's theorem. And then finally, just now we have done mesh analysis. So final answer using mesh analysis. So in this, there is a shortcut way. Actually, instead of doing this step, so actually we made one step here and then we jumped it. It is also possible to directly come from the circuit to directly this matrix. So it just comes by a little bit of more practice. So hopefully in the next few videos we'll try to do that. So by the way, this is part 6. So continuation of the previous videos. So I hope you learned something from these last 3 videos about analyzing the same circuit with different theorems and then cross-checking the answer. So we'll do more such problems in future. See you.